Welcome to this mini tutorial for DBGene Online. The goal of this tutorial is to guide you through the main steps of developing a decision support application with DBGene Online. To achieve this, we will use a classical optimization problem. We will start with a simplified version of the problem, which we will then refine iteratively. The steps in this tutorial include bootstrapping the application by defining a data model, that is, the structure of the data handled by the application. We will first only define the structure of input data, and later in the tutorial we will add structure for output data. Importing data and performing an initial visual analysis of the input data. Writing code to implement our business logic in a Jupyter Lab notebook. Extending the data model with entities for output data and running our business logic. Designing additional dashboards to visualize the computed solution. Additional steps will then be proposed as exercises. The problem we'll address in this tutorial is known as a fulfillment optimization problem. On one side, you have an inventory of products, each with a specific stock quantity. On the other side, you have a list of sales orders, each requesting a given quantity of various products. How will you fulfill these orders, especially if you do not have enough inventory? In the simplified version of our fulfillment optimization problem, we aim to ensure that the available products in our inventory are used in the most profitable way. Here, we define profitable in a simplistic manner, which means prioritizing the fulfillment of sales orders with the highest unit price. Enhancements to the problem definition could include profit margins, considering sales revenue, production, and fulfillment costs. Customer behavior for long-term profitability. Service level categories, indicating the importance of fulfilling a given sales order in the current cycle. Order flexibility, such as whether a sales order can be partially fulfilled or delayed. Customer segmentation, product characteristics, etc. When we open our application for the first time, the data model editor appears, allowing us to input our data model. Why a data model? The data handled by the application is displayed in dashboards, stored in database, and processed by algorithms that rely on its structure to provide consistent services. This data structure is defined by the application's data model, which is expressed in the data model editor using a semi-proprietary language. Based on Gipster's JDL, the data model we will define consists of 3 entities and 2 relationships. SKU, for stock keeping unit, describes a product with a stock quantity. Sales order and sales order item describe how much of each SKU is ordered. Let's start with the SKU entity to model the stock keeping units. In our simple data model, an SKU has an identifier and a name. In addition, a certain quantity of each SKU is stored in the inventory. This results in the following definition. Let's copy or type this definition into the data model editor, after or in place of the big comment block. We can see that an error is signaled. This is due to the type of attribute stock quantity being misspelled. When we replace it with integer, the error disappears. The SKU entity as just defined contains the bare minimum to model SKUs in our problem. Yet, we can enhance it with 3 kinds of improvements. Descriptions that document the entity and its attributes will be used in UI tooltips. Constraints on the attribute values will be automatically checked. Indications on primary key used by the database and in relationships. This gives the following definition. In this enhanced definition, we still have the entity and attributes definitions. We added a description annotations to document them. We indicate that generated code that refers to collections of SKUs should use the term SKUs. All attributes are required, that is, must not be null. The primary key is automatically marked as required. The stock quantity must be non-negative and defaults to 0. In our simple data model, sales orders are received from customers and include a list of items that associate SKUs with quantities and prices. We will be defining 2 entities to model sales orders, sales order and sales order item. We will also introduce a relationship between these 2 entities to model that a sales order contains several items. Here is the definition of the sales order entity, with the descriptions, constraints, and primary key indications. A sales order consists of several sales order items, each indicating the required quantity of a given SKU and its unit price in the sales order. This gives the following definition for the sales order item entity. As you can see, the relationship between items and sales order is not included in this definition. We express this relationship with a separate construct, namely relationship many to one, as there may be several items in a sales order. In this definition, the DOM affects primary.key true indication specifies that the sales order attribute that is created in sales order item will participate in the primary key of the entity. A sales order item also refers to an SKU. We express this with a second relationship of the same cardinality, as an SKUs may be referred to by several sales order items. The complete input data model, combining all elements introduced in previous sections, can be found in this file. The reference documentation on the various constructs of the JDL language used by DBGene Online to define a data model is accessible at this link. Once you have filled the data model editor of your DBGene Online application, click on the Rebuild button. This initiates the rebuilding process of the application based on the defined data model. During this time, a wait screen appears for a few seconds. A simple way to populate an application is to import data from an Excel spreadsheet. The structure of the spreadsheet has to follow the structure of the data model. To kick the ball rolling, we start by downloading a template of such a spreadsheet from our application. We can now fill this spreadsheet with sample data, either by hand or with the help of your favorite LLM. For example, here is an Excel file that was generated by ChatGPT 4o using the following prompt, then slightly cleaned up by hand. A dataset is called a scenario. To import our sample dataset, we will thus create a scenario by clicking on the plus button on the top right corner of the scenario list. In the dialog box that appears, drop the sample data, XLSX file, adjust the scenario name if you want, and click Import. The dataset is then uploaded to the application and checked for compliance with the constraints expressed in the data model. The dataset that we just uploaded has been checked for compliance with the constraints expressed in the data model. As our sample dataset was generated by ChatGPT, it actually contains errors. You can see that the dataset contains errors by the error value in the data status column, or by the red dot on the scenario icon. Let us now investigate the errors and fix them. To investigate the errors, let us create a data explorer. We start by creating a dashboard with the new dashboard button. We name it Data Explorer. We select it in the left bar, and we click on the text at its center to add a widget in the dashboard. Finally, from the Select a Type of Widget drop-down, we select Data Explorer. The configurator of a Data Explorer widget is then presented. We are going to use the default settings, so simply click Save at the bottom of the page. Let us resize the widget to the full width of the dashboard by clicking Edit on the top right, then dragging the bottom right corner of the widget, and finally clicking the green checkmark button. In the scenario picker at the top of the dashboard, select our sample data scenario. This populates the Data Explorer with the contents of our dataset. By clicking the entity names in the left column of the Data Explorer, we can see the data that was generated for us by ChatGPT. The Data Explorer signals that there are 20 errors with the sales order items. If we select it and we hover over the exclamation mark icon in the first column, we get information about the error. Indeed, ChatGPT, or our prompt, did not prevent duplicates in the composite primary key. Let us fix that. With the sales order items entity selected in the Data Explorer widget, we start by clicking the pencil icon in the widget toolbar. This enters addition mode. We then delete rows where the sales order plus SKU pair is a duplicate of another row. This is done by clicking in any cell of the row, then on the minus button of the toolbar. We repeat the delete row operation on the 10 duplicates, and we save the changes by clicking on the checkmark button of the toolbar. The dataset is then automatically checked again to find out that there are no errors anymore. The scenario icon now carries a green dot. Before writing the decision procedure, we're interested in knowing more about our data. To this end, we will leverage DBGene's powerful UI components to build the following simple dashboard. We start by creating a second dashboard and naming it Input Data. We select it in the left bar, and we click on the text at its center to add a widget to the dashboard. We are first adding a KPI widget to display the total stock in our inventory. The configurator of the KPI widget is then presented. Let's go through the tabs of this configurator to shape the widget like we want. In the General tab, we are setting the widget's label and description. In the Data tab, we are defining how the value of the KPI is computed. We sum the stock quantity attributes of all SKU instances. Finally, in the Formatting tab, we are choosing the number format for the widget, and we are coloring it in green. Then we click Save to complete the widget creation. To create and configure the second KPI widget, we start by clicking Edit in the Dashboard toolbar. The Add a Widget in the Dashboard Addition toolbar. We add a second KPI widget, which we configure as follows. We'll be adding a third widget to our dashboard, namely a bar chart with two series: the available stock for each SKU, and the total demand for this SKU. To this end, click the Add a Widget button again, and add a chart widget. In the configurator of this widget, we start by setting the name and icon displayed in the widget header. We then switch to the Chart Series tab, where we will add the two series. We start by adding a series that plots the stock quantity of each SKU. After clicking the plus button, we configure it as follows. This configuration states that the chart has one green bar for each SKU, labeled with the SKU name. The height of each bar comes from the SKU stock quantity. The aggregation setting is useful when there are multiple SKU with the same name. Here, we can select any of max, min, sum, etc. Note the descending sort that gives a nice finish to the chart. We now add a second series that plots the total demand of each SKU across all sales order. After clicking the plus button, we configure it as follows. We perform a similar configuration, but we start from the sales order item entity. For the x-axis, we still use the SKU name. For the y-axis, we sum the quantity attribute of all sales order items with the same SKU name. Also, we change the color to orange, to match the color of the second KPI widget. We can now record our widget configuration by clicking Save at the bottom. After saving the third widget, the dashboard is still in edit mode. We did not care about the layout of the widgets, so the dashboard looks like this. By moving the widgets around and resizing them, you can achieve the layout that suits you. Your dashboard is ready. You can hit the green checkmark button. We have just built a dashboard with two KPI widgets and one bar chart widget to analyze our input data. In particular, the bar chart allows us to spot that we will not be able to fulfill all the sales orders on SKU 13, 11, 14, and 10. The two dashboards that we have created so far can be exported out of the application. This can be useful if you want to keep a snapshot of your application configuration before trying out new things. The export is achieved by the Export to File command. Importing a configuration is done using the Reset from File command. You will be asked for confirmation. The confirmation dialog includes concepts that are not covered here. Uncheck the Workspaces and Folders box, check the Confirmation box, and click Reset. Note that you will then have to select the Sample Data scenario again. The simple dashboard that we created shows that we have enough stock of our products to fulfill most of the sales order, but not all. We thus need a decision procedure to tell which sales order will be fulfilled, up to which quantity. As stated in the introduction, there are numerous strategies for this, and for this tutorial, we chose to adopt a very simple one, in which we fulfill the orders in the most profitable way for us, that is, by prioritizing the sales order items with the highest unit prices. We are going to develop a small Python program for that, using a JupyterLab notebook coupled with our application, so that the input for this program is taken from our dataset and its output is saved back in our dataset, too. To this end, let us launch JupyterLab with this command. This opens a new tab in your browser, where we'll interact with JupyterLab. The first steps are about establishing a secure connection between JupyterLab and your DBGene Online application. On the one hand, we need to authenticate to JupyterLab. Simply enter Gene as the token requested by JupyterLab. On the other hand, we need to generate an API key in our DBGene application and provide it to our JupyterLab notebook. Back to the DBGene application, open the API key management page. Start the API key creation process by clicking the plus button of the toolbar. Then enter a name for the API key and click Create. A dialog appears with your API key. You will soon copy the API key by clicking the Copy button. For now, just leave the dialog open. Don't close it now, as you will no longer be able to access the key once this dialog is closed. In the JupyterLab tab of your browser, open this notebook by double-clicking it. The first cells of this notebook contain a bit of documentation and some sample code. To complete the secure connection between the notebook and our DBGene application, we want to scroll to the last cell of the notebook and paste the API key we just created in the 8th line of this cell. So that it looks as follows. You can then either have a detailed look at the code in the cells before executing them, or simply execute the whole notebook with the Run All Cells menu entry to initialize the connection with the DBGene application. The following block will appear after the last cell. To complete the initialization, select DataFrame API from the Use API dropdown. Do not click the Run Engine button, as we'll write our own procedure. Now that the notebook is connected with the DBGene application, let us load our dataset from the sample data scenario into a dictionary of pandas dataframes. As a result, the scenario data variable contains the data from the SKU, sales order, and sales order item tables as a dictionary of data frames, indexed by the entity names. We are now ready to solve our fulfillment problem. We know that we want to prioritize the sales order items with the highest unit price. We thus start by sorting the sales order items in descending order. We will also need to maintain the remaining stock for each SKU. Finally, we iterate on the sales order items and fulfill them as much as we can. The next thing we want to do is to save the solution we just computed into the scenario. However, we do not have a place in the data model where to store the solution. There are basically two approaches on where to store the output of our decision procedure. We can add a fulfilled quantity attribute to the sales order item entity. We can add a new entity that stores the fulfilled quantity with a reference to the corresponding sales order item. There is no good or wrong answer. Here, we are choosing the second approach because we like to keep our input and output entities separated in the data model. To this end, back in the Gene app, we open the data model editor from the menu. We can then see again the JDL code that we authored in the first section of this tutorial. We are going to augment it and rebuild the application. In the general case, changing the data model makes the scenarios invalid. This is why scenarios are deleted on application rebuild. Here though, you will be able to reuse the same input data file. In the data model editor, add a new entity named sales order item fulfillment that stores the quantity that has been assigned to a given sales order item by the decision procedure, and a new one-to-one relationship from the sales order item fulfillment entity to the sales order item entity to encode the sales order item to which a given fulfillment relates. This corresponds to the following JDL code. For reference, here is the JDL for the entire data after this addition. We can now hit rebuild to adjust the application to the augmented data model. After a minute, the DBGene application has been rebuilt with the extended data model. We import the dataset again with the plus button of the home page, as described previously. You can use the corrected dataset from this file. You may want to adjust the scenario name to sample data. Back in the Jupyter Lab notebook, we need to reload the dataset, then execute the decision procedure again. To this end, execute the Run All Cells menu entry, which will select the scenario again, load its data and compute our fulfillment of the sales orders as a data frame stored in the fulfilled orders variable. The last step is to save the results in the scenario to see them in the DBGene app. The data of a scenario is handled in the notebook as a dictionary of data frames. We have stored the fulfillment results in a data frame. We now need to add this data frame to the dictionary. The last step is to save the dictionary in the application's database. For reference, here is the final notebook. Remember to insert the API key as explained previously. The data of our scenario has been updated from the notebook, as we can witness by looking at the sales order item fulfillment table in the Data Explorer. This means that our decision procedure has allocated 10 units of SKU 3 to sales order 11. We'll see in the next section how to build a new dashboard to analyze further the solution. We now want to add a dashboard to further analyze the solution produced by our decision procedure. In this dashboard, we would like to see the requested and fulfilled quantities, by SKU and by customer. We are also interested in the service level, that is, the ratio of fulfilled over requested quantities, globally and by customer. We will start by building a dashboard with 2 bars charts. We will then augment the data model and the notebook to compute service levels, and add them to the dashboard. We start by creating a new dashboard and naming it Solution. We select it in the left bar, and we click on the text at its center to add a widget to the dashboard. To display the 2 bars charts under tabs, we add a composite widget. The configurator of the composite widget starts with 2 tabs. For each of them, we will choose a chart widget. To configure the bar charts, we follow similar steps as we did when analyzing input data. We start with the chart header. We then select the Chart Series tab, where we will add 2 series. The first series plots the total required quantity for each SKU. This configuration states that the data is aggregated by SKU name. The height of each bar represents the sum of the quantity requested in the sales order item for this SKU. The chart has orange bars based on data from the sales order item entity. The descending sort that gives a nice finish to the chart. The second series plots the total fulfilled quantity for each SKU. This configuration states that the chart has cyan bars based on data from the sales order item fulfillment entity. Data is again aggregated by SKU name. The height of each bar represents the sum of the fulfilled quantity allocated in the sales order item fulfillment for this SKU. We can now proceed to the second tab, in which we also select a chart widget. The configuration of the 2 bars charts by customer is similar to the previous ones. We can now record our widget configuration by clicking Save at the bottom. Let us resize the widget to the full width of the dashboard by clicking Edit on the top right, then dragging the bottom right corner of the widget, and finally clicking the green checkmark button. As mentioned before, the application configuration can be exported out of the application. This can be useful if you want to keep a snapshot of your application configuration before trying out new things. The export is achieved by the Export to File command. Executing the Export to File command at this point of the application development yields the following configuration file. In addition to the bar charts on requested versus fulfilled quantities that we just created, we are interested in analyzing the service level, globally and per customer. We define the service level as the ratio of the fulfilled quantity over the requested one. A simple way to compute these service levels is to augment our Python script and store the results in the scenario. To this end, we are introducing an entity dedicated to storing KPIs related to customers. As before, we open the data model editor from the menu. We then add the JDL definition of our new entity. For your reference, the resulting JDL can be found in this file. When we hit the Rebuild button after adding the JDL definition of our new entity to the existing data model, the application will be refreshed. Remember that, as a consequence, all the scenarios present will be removed. If you want to export your scenarios before entering the data model editor to perform your edits to the data model, you can do so by exporting them to Excel files, which you'll later use to recreate the scenarios. Tip: you can get back to the scenario list page by clicking on the application logo in the top left corner of the web page. We choose to compute the customer-related KPIs using some Python code. This can be done in the same notebook where we computed the fulfillment of sales orders, or in a dedicated one. Let's reuse the same notebook as in section writing a decision procedure. Since we rebuilt the application, the connection between the notebook and the application has to be restored and the scenario loaded again. To this end, we execute again the first cells of the notebook that set up the API key, present the existing scenarios in a drop-down where you select the one you want to load the scenario data. If your scenario does not contain fulfillments, you will also need to execute the subsequent cells. Otherwise, you can jump to the end of the notebook. The KPIs we want to compute are based on the sales order item and sales order item fulfillment tables. As a reminder, these and other tables are stored in a dictionary of data frames in the scenario data variable, with the table names as indices. For our computation, we want a data frame that looks like the sales order item, with the addition of the fulfilled quantity, as well as the customer name coming from the sales order. To this end, we will perform two merge operations. We start by keeping only the useful columns in the three data frames involved. Then we add the fulfilled quantity. And finally the customer name. As a result of these two merge operations, we have a data frame that contains all the columns we need. We will compute the KPIs by iterating on the customers. Let us extract the customer names. As for the order fulfillments, we collect the KPIs in a list of small dictionaries where the keys are the column names of the customer KPI entity. Finally, we iterate on this list to add the service level. We can now store the KPIs as a data frame in the scenario data dictionary. And save the scenario to the database. For reference, here is the final notebook. Remember to insert the API key as explained previously. Now that we have the data in our scenario, we create a new dashboard. We name it Customer KPIs, and we select it in the left bar. In this dashboard, we want to add a bar chart that shows the service level by customer, and a KPI widget that displays the global average service level. Let's start with the KPI widget. Click on the text at the center of the dashboard to add a widget. Select KPI from the drop-down of widget types. The configurator of the KPI widget is then presented. Let's go through the tabs of this configurator to shape the widget like we want. In the General tab, we are setting the widget's label and description. In the Data tab, we are defining how the value of the KPI is computed. We sum the stock quantity attributes of all SKU instances. Finally, in the Formatting tab, we are choosing the number format for the widget. Then we click Save to complete the widget creation. To create and configure the second KPI widget, we start by clicking Edit in the Dashboard toolbar. Add a widget in the Dashboard Addition toolbar. We select the chart widget type, and we'll configure it in the next screens. To configure the bar chart, we follow similar steps as when at the beginning of this section. We start with the chart header. We then select the Chart Series tab, where we will add one series. The configuration of this bar chart is similar to the ones we've seen before. We can now record it by clicking Save at the bottom of the configurator. We can resize the bar chart to the full width of the dashboard, and finally clicking the green checkmark button. You now have a customer KPIs dashboard that displays the service level, globally and per customer. As mentioned before, the application configuration can be exported out of the application. This can be useful if you want to keep a snapshot of your application configuration before trying out new things. Executing the export to file command at this point of the application development yields the following configuration file. You have reached the end of this tutorial. We encourage you to look at the other resources available from the resources page to go further on your journey with DBGene Online.